All right, guys, example 6. In example 6, we're given the matrix P, Q, R, and the matrix S. P is a 3 by 2 matrix. Q is a 2 by 3 matrix. R is a 2 by 2 matrix. And S is a 2 by 1 matrix. IX is asking us, without doing the actual multiplication, we're being asked to determine the order of the matrix product PQ. All right, so P is a 3 by 2 matrix, indicating that P has 3 rows and what? 2 columns. We're multiplying this now by Q, which is a 2 by 3 matrix, indicating that Q has 2 rows and what? 3 columns. Ladies, 2 matrices are compatible for multiplication when the number of columns in the first is equal to the number of rows in the second. So we can see that yes, we can multiply P by Q because the number of columns in the first matrix is equal to the number of rows in the second matrix. Now, when 2 matrices are compatible for multiplication, the number of rows in the first matrix, which is 3, multiplied by the number of columns in the second matrix, which is also 3, is the order of the matrix product PQ. So PQ, the matrix PQ will be a 3 by 3 matrix. In other words, the matrix PQ will have 3 rows and 3 columns. Guys, when 2 matrices are compatible for multiplication, the number of rows in the first matrix by the number of columns in the second matrix is the order of the matrix product. All right, so we just did A. Let's turn the page and have a look at B. We're asked to determine the order of the matrix product PR without doing the actual matrix multiplication. Without doing the actual multiplication, I need to state the order of the matrix product PR. Now, P is a 3 by 2 matrix. It has 3 rows and 2 columns, and R is a 2 by 2 matrix. It has 2 rows and 2 columns. Now, 2 matrices are compatible for multiplication when the number of columns in the first is equal to the number of rows in the second. The number of columns in the first matrix is 2. The number of rows in the second matrix is 2. So that makes the 2 matrices compatible. Now, the number of rows in the first matrix is, which is what? 3, by the number of columns in the second matrix, which is 2, is the order of the matrix product. So what this is saying to me is that PR is a 3 by 2 matrix. So this is the order of PR. This is the order of PR. And that's what we're asked to do. We're asked to determine the order of the product, the matrix product, without doing the actual multiplication. Guys, see, so R is a 2 by 2 matrix. 2 rows and 2 columns. S is a S is a 2 by 1 matrix, 2 rows and 1 column. Now, two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. So yes, the matrix product PS is possible because, sorry, RS is possible because RS is compatible. The number of rows in the first matrix, which is 2, by the number of columns in the second matrix, which is 1, is the order of the matrix product. So I could say that RS, when you do the multiplication, is another 2 by 1 matrix. And of course, 2 by 1 is the order of the matrix product RS. Lastly, let's do the same now for RQ. RQ, there's a Q, yes, there's a Q. R is a 2 by 2 matrix. 2 rows, 2 columns. Q is a 2 by 3 matrix. 2 rows, 3 columns. Two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. So that makes them compatible. And once they're compatible, the number of what rows in the first matrix, which is 2, by the number of what columns in the second matrix, which is 3, is the order of the matrix product. So what this is saying is that RQ will be a 2 by 3 matrix. And of course, this is the order of RQ. Next, guys, we're asked now, by multiplying, determine the matrix product PQ. So now they want us to do the actual multiplication. By multiplying, we're to determine the matrix product PQ. So let's multiply P by Q. P is 2, 1, 0, minus 3, 4, minus 2. This is P multiplied by Q. Q is minus 2, 1, 3, and 4, 0, minus 1. All right, so we're going to multiply these two matrices. All right, so we're multiplying P by Q. Whenever we multiply two matrices, we multiply the rows of the first matrix by the columns in the second matrix. I've just identified the first and second element in the top row and the first and second element in the left column. Guys, if I multiply the top row by the left column, I'm going to get the top left element in the answer. So I'm going to multiply the first element in the row by the first element in the column, then the second element in the row by the second element in the column. So it's 2 times minus 2, which is minus 4, and minus 3, which is the second element in the row, by 4, which is the second element in the column. Minus 3 times 4 is minus 12. I just multiplied the top row by the left column. Next, I'm going to multiply the top row by the middle column. I just identified the first and second elements in the column. Now, if I multiply the top row by the middle column, I'm going to get the top middle value. First by first, second by second. So it's 2 times 1, which is 2, and then minus 3 times 0, which is really still 0. Next, I'm going to multiply the top row, but this time now by the right column. If I multiply the top row by the right column, I'm going to get the top right element in the answer. First element in the row times the first element in the column. So that is 2 times 3, which is 6. And then the second element in the row times the second element in the column. That is minus 3 times minus 1, which is positive 3. Ladies, I just multiplied the top row by all 3 columns. Next, I'm going to multiply the middle row by all 3 columns. All right, middle row, left column. Now, once I multiply the middle row, it means I'm going to get the elements in the middle row for the answer. I multiply the middle row, so I'm going to get the elements, the middle elements in the answer, in the product. You want to multiply the first by first, second by second. So it's 1 times minus 2, that's minus 2, and then 4 times 4, which is 16. So that is middle left. Next, I'm going to multiply middle by middle. So that's going to give me the extreme middle answer. First by first, second by second. So 1 times 1 is 1, and 4 times 0 is 0. All right, so lastly, I'm going to multiply the middle row by the right column. That is going to give me the middle right element. First element in the row times the first element in the column, then second element in the row times the second element in the column. So that's 1 times 3, which is 3, and then 4 times minus 1, which is minus 4. I just multiply the middle row by all of the columns. Next, lastly, I'm going to multiply the bottom row by all 3 columns as well. So that's bottom row, left column. First element in the row times the first element in the column. So that's 0 times, so let me identify these, the first and second. That's 0 times minus 2, which is 0. And then minus 2 times 4, which is minus 8. All right, bottom row, middle column. Zero times 1 is 0. And then minus 2 times 0 is still 0. And lastly, middle row, right column. First, second. 0 times 3 is 0. Minus 2 times minus 1 is positive 2. The final answer is minus 16. If the signs are the same, add and keep the sign. 2, 9, 14, 1, minus 1, minus 8, 0, 2. So this is the matrix product PQ. I just did A, please do B, C, and D. I just did A, please do B, C, and D. So next we're going to multiply R by Q. So R is the matrix 1, minus 1, minus 2, 3. And Q is the matrix minus 2, 1, 3, 4, 0, minus 1. So we're multiplying R, which is a 2 by 2 matrix, by Q, which is a 2 by 3 matrix. We should end up with another 2 by 3 matrix. All right, so remember, whenever you multiply two matrices, you multiply the rows of the first matrix by the columns in the second matrix. And every time you multiply a row by a column, you get an element in the answer. So if you multiply the top row by the left column, you're going to get the top left element in the answer. First by first, second by second. First element in the row by the first element in the column, and the second element in the row by the second element in the column. So 1 times minus 2 is minus 2. Minus 1 times 4 is minus 4. I just multiply the top row by the left column. Next, I'm going to multiply the top row by the middle column. First element in the row by the first element in the column, second element in the row by the second element in the column. So it's 1 times 1, which is 1, minus 1 times 0, which is still just 0. You could say plus 0 or minus 0, it doesn't matter, because if you add or subtract 0 from a number, the number is unchanged. So I always just write plus 0. Next, we're going to multiply the same top row by the right column. First element in the row by the first element in the column, second element in the row by the second element in the column. So it's 1 times 3, which is 3, and minus 1 times minus 1, which is 1. So this is 3 plus 1. So next, I'm going to multiply the bottom row by the leftmost column. If I multiply the bottom row by the left column, I'm going to get the bottom left element in the answer. You're going to multiply the first element in the row by the first element in the column, then the second element in the row by the second element in the column. So it's minus 2 times minus 2, which is positive 4, and then 3 times 4, which is 12. Now, bottom row, sticking with the bottom row, but moving on to the middle column. First element in the row by the first element in the column, second element in the row by the second element in the column. Minus 2 times 1 is minus 2, and then 3 times 0 is 0. And then now, lastly, bottom row, right column. That will give us the bottom right element for the answer, the last element. First element in the row by the first element in the column. So that is minus 2 times 3, which is minus 6. And the second element in the row, 3 times the second element in the column, minus 1. 3 times minus 1 is minus 3. And so our final answer is minus 6, 1, 4, 16, minus 2, minus 9. That is our final answer. So let's go to C. C is multiplying P by R. So P is 2 minus 3, 1, 4, 0, minus 2, that's P, multiplied by R, 1, minus 1, minus 2, 3. Okay. All right, so now we're multiplying a 3 by 2 matrix by a 2 by 2 matrix. We should end up with another 3 by 2 matrix. So these are the first and second element in the top row and the left column. First element in the row times the first element in the column. So that's going to give us our top left elements. You're going to multiply first by first, second by second. So it's 2 times 1, which is 2. And then minus 3 times minus 2, which is positive 6. All right. If I wanted to know, I could move over. Let me do it going down this time. I'm hoping it won't be confusing to anybody. I'm going to go now to the middle row. Same left column. So if I multiply the middle row by the left column, I'm going to get the middle left element. First by first, second by second. So it's 1 times 1 is 1. 4 times minus 2 is minus 8. I'm going to multiply now the bottom row by the same left column. First by first, second by second. So 0 times 1 is 0. Minus 2 times minus 2 is positive 4. I just multiply the left column by every single row on the left. Now I'm going to multiply the right column by the same 3 rows. So right column, top row. That's going to give me the top right element. First by first, second by second. 2 times minus 1 is minus 2. And minus 3 times 3 is minus 9. All right, so middle row, same right column. First by first, second by second. 1 times minus 1 is minus 1. 4 times 3 is 12. Now, bottom row, same right column. 0 times minus 1 is 0, and minus 2 times 3 is minus 6. So our final answer should be 8 minus 11 minus 7, 11, 4 minus 6. All right, so next we are going to multiply P by S. This is 2 minus 3, 1, 4, 0 minus 2. This is P multiplied by S, which is 2, 5. So P is a 3 by 2 matrix, and S is a 2 by 1 matrix. So we should end up with a 3 by 1 matrix. So we should end up with a 3 by 1 matrix. So let's multiply. Top row. So we're going to multiply the 3 rows by the 1 column. There's only 1 column. So we're going to multiply the 3 rows by the 1 column. First, second, first, second. Top row. First by first, second by second. So it's 2 times 2, 4. Minus 3 times 5 is minus 15. That's top row multiplied by the 1 column. So now let's go middle row by the same column to get the middle value in the answer. First by first, second by second. 1 times 2 is 2. 4 times 5 is 20. Lastly, bottom row, same column. 0 times 2 is 0. Minus 2 times 5 is minus 10. So our final answer is 4 minus 15 is minus 11. 2 plus 20 is 22. 0 minus 10 is minus 10. This is the answer. So if I multiply a 3 by 2 by a 2 by 1, I'm going to end up with a 3 by 1 matrix. All right, so RS, R is 1 minus 1 minus 2, 3, multiplied by S, which is 2, 5. So we're multiplying a 2 by 2 with a 2 by 1. We should end up with another 2 by 1. All right, so we're multiplying the rows of the first matrix by the columns in the second matrix. 1, 2, 1, 2. So first by first, second by second. 1 times 2 is 2. Minus 1 times 5 is minus 5. And then lastly, bottom row by the 1 column. First by first, second by second. Minus 2 times 2 is minus 4. And then 3 times 5 is positive 15. So this is 2 minus 5, which is minus 3. And minus 4 plus 15 is positive 11. So that is the matrix product RS. Here it is. We're asked to state why the matrix product QR is indeterminate. So in other words, we need to say why we cannot multiply Q by R. So let's test it. Q is a 2 by 3 matrix. This is row by what? Column. And R is a 2 by 2 matrix. This is row and this is what? Column. Now guys, two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. Two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. So the issue here, but what we'll notice here is that the number of columns in the first matrix is 3, and the number of rows in the second matrix is 2. So since these two values are not the same, the matrix product QR is not compatible. So QR is indeterminate because QR is not compatible for multiplication. In other words, I might be able to multiply R by Q, but I cannot multiply what? Q by R. QR is indeterminate because QR is not compatible for multiplication. And they are not compatible for multiplication because the number of columns in the first matrix, which is 3, is not the same as the number of rows in the second matrix, which is 2. So QR is indeterminate because QR is not compatible for matrix multiplication.